Okay, so here we are, doing a bit of basic research. Why not? Important to game, to learn how to develop games. Let's have a look at the jumping system. So of course, here's how it goes. We press space, we can jump. We can press space twice to sort of double jump. How many times can we do that? Once, twice, 3 times, 4 times. Seems to be a sort of recharge system. So when we implement this, the way I'm going to do it is just when I hit the ground, everything recharges. So I can go 3, something like that. Now we can also sort of hit space and hold it, and that'll float. So jump, float, double jump, float, like that. But it doesn't last forever. So for instance, if we go out here and we try to just float forever, there's sort of a limit where we drop out, because otherwise we'd just be floating forever. That's not so good. Okay, so let's try implement this in our system in Python. Okay, so here we are back in the command center. I'm going to start with the model classes and build our way outwards. I want to sort of do some physical modeling, but these parameters will need tweaking. So let's start this off. Let's have position, velocity, and acceleration. Okay, now we're going to have a number of terminal velocity variables. There's going to be a general terminal velocity parameter, which will be one of two things. We've either got a state where we are directly falling down, or we're falling and sort of floating. Oh yeah, good point. We can go to the acceleration and we'll add acceleration due to gravity. Now, I actually tried using physically correct parameters. I Googled the terminal velocity of a person. Funnily enough, it was really hard to find the terminal velocity of a parachute. I kept Googling it, and the only thing I could find was the world record for falling the fastest. But I just want to know, like, why are people so keen to fall down to the ground? I don't know. They want to do it as fast as possible. Okay, point was, it didn't look good, so I've sort of stylized these numbers a little bit. These are not physically accurate, but they do sort of seem to go okay with the controls. Okay, so then we have the jumping state. So if jumping is false, then the player is on the ground. If jumping's true, doesn't necessarily mean they're in the act of jumping. It just means they're up in the air somewhere with some physics acting on them. Now we also want to keep track of the number of jumps which have been performed before the player hit the ground. So when the player hits the ground, that'll be reset to 0. And when the space bar is pressed, we'll be testing this to see, does the player have fuel, basically, to jump again. We also want to keep track of whether the space bar is down. Now we can do this other ways, but I'm just going to use a simple Boolean variable and update that to check whether we should be floating. Now, we have some float parameters. We have, what is it? We're going to have the time that we've been floating, and we're going to have the maximum time that we can float for. So I'm going to do it for 5 seconds, so 5,000 milliseconds, and that's how we're going to do it. Also, I'm going to make a color parameter because I'm going to be encoding some of the state in the color just for easy debugging. So we're just going to have one for the blue, and then the red channel will be the jump state, so the number of jumps which have been performed in an event, and the green channel will be whether the player is floating or not. So we can then go to the renderer and update this so that it is drawing the player in the appropriate color. So down here to the, where are we? Render. And then here, where we're passing in this color, this is for the player. Let's change that. So we'll go, whoops, scene, player, color. Okay, we can actually run this and check. Right now the player should be blue. Yep, the player is blue, and we can move around and do all the stuff that we did before. Okay, so back to the model. So let's take it one step at a time, and we'll start with the simplest, which is the function which will get the player jumping. And I'm going to call that apply impulse. So an impulse is a burst of energy delivered over a very short time. And that's what I'm going to do here. So when we hit space, we're going to apply a burst of energy to the player. Where was I? Okay, we'll go... so I'll make a function called try jump. So, okay. What happens when the player tries to jump? Well, the first thing we should do is check for any exit cases. So the exit case really is if we're in the air and we're out of juice. So we'll go, if we are jumping, and our jump count is bigger than 3, then simply return. And then if we haven't returned, then we're good to go. So just make sure the jumping state is set to true. Okay, so what do? We set jumping to true. We increment the number of jumps by 1. We reset the float counter. So if we were floating in the air and then we jumped again, this gives us an extension on our float time. And now what we're going to do is generate impulse. Now the impulse, the way I'm setting this up is if we just hit space, it will pretty much just jump directly up. If we hit space and an arrow key, then we'll have a direction and an amount will be passed in. And the amount will make us sort of jump forwards, jump to the side, that sort of stuff. Okay, so here we have generated an impulse by this formula. The horizontal movement is controlled by whether an arrow key was pressed at the time of jumping, and the vertical movement is always there. So we can then go self apply impulse and pass that in. Okay, so we can see we can see at the moment, if we go down to the scene, that the player doesn't really have an update function. So in future, we will make a full update function, but right now, I'm just going to make a simple function that just calculates the jumping movement. And I'll be very imaginative and I'll call it calculate jump. Oops. Sorry, I'm looking at my notes. I'm typing the wrong function. Okay, so calculate jump. What we're going to do is we're going to... Actually, I won't worry about that just yet. Okay, so we're really going to do physics. So we'll take our velocity, increase by delta t. Oh, geez, I copied everything from my notes. That's not good. That is not good. Okay, we'll go delta t by our acceleration. And then I want to set up a check to see if I can start floating. So what are we going to do? There's a number of conditions. First of all, the z component of our velocity needs to be less than the terminal floating velocity. right? So this makes us go up a little bit. Then as we come down, we catch that floating velocity and start floating. The next condition is that spacebar needs to be pressed, and we need to be in the air. There's a lot of conditions here. And of course we need our float time to be less than our maximum float time. And we need the number of jumps. We can't just be floating and jumping around forever. Okay. So with that done, we can then apply floating operations. And I just realized it's probably a good idea to also keep track of this with a variable. Okay, so where were we? Of course, our terminal velocity has to be, we have to select the floating velocity to apply there. Then we increment by the number of milliseconds. So if dt equals 1, this corresponds to sort of a rate of 60 frames per second. So 17.67 milliseconds per frame. And I'm also going to set the the green channel of our color to 1. Oh, and of course, floating equals true. Alrighty. Okay, so we set the color, and I guess if we're falling, we should set floating to false. Okay, so this is really just choosing the terminal velocity based on whether we can float or not. Then what we can do is we can set the z component of the terminal velocity z component of the velocity based on the terminal velocity. So we take our velocity, and if our velocity is less than, meaning it's negative and it's pretty large, basically we cap it according to our terminal velocity. So our terminal velocity is the maximum speed at which we can fall. Then we take our position, and then we just calculate if we've hit the ground. This is just checking, basically setting our velocity to 0 in all components, because we're floating around forwards and then we hit the ground, we want to stop immediately. Okay, now we'll go self-jumping, false, self-floating is false. So we basically want to reset all of the variables associated with jumping and floating. Okay. Also, we want to set the red component of our color. Because the jump can be anywhere between, I guess, 0 and 3, then we just keep track of that. So this will range from 0 to 1 on the red. Okay. Now, there's a few other things to do, and one of those is if I'm not able to float, then I want to set my float t to the maximum, and this is just ensuring that I'm not magically able to float again midway in the air. Just double checking this. Okay. Yeah. Because then when I hit the ground, I will actually reset that counter. So just to be sure, let's add another 10 milliseconds. Why not? Okay. So the other things I need to do is, if I look at this movement function, then I'm going to use that, grab the model transform. And the other thing I'm going to do, this is just a little thing right now, is I'm going to say, okay, well, remember, when I was floating, I actually wasn't able to strafe. So I'll just do this for now. I'll say if I'm floating, when I attempt to move, set that variation to 0. So I'm just moving at the camera's direction. Hopefully that works. Now, there was one other thing I was going to do. When I move the camera, I want to return that movement amount to apply it. When I move the player, I want to return the movement amount to apply it to the camera as well. But I'm tempted. I might want to just return the velocity. However, that's not going to work because we've got this ground is sort of resetting the velocity and things. So another way to do it is to, at the start of the function, grab the old position by taking a copy of our position and then return the difference, the actual difference in positions between frames. Okay, I'm pretty happy with that. So we've got these functions. Now let's look at the scene. So in the update, like I said, I'm going to get the movement. And then I'm going to move the camera according to that. All right, so we have sort of two helper functions that the scene is going to have, which will take signals from the control, the app, and pass them along to the player. First of all, we want to indicate whether the spacebar is currently down. And this is pretty straightforward. Whoops. We'll simply pass that along. And then we have the try jump function. And these functions are not very exciting. They just pass their arguments down the line and let the player handle it. Okay, so that's that. Let's look at the control. And we'll go to the app. And I'm going to refactor this a little bit. So here we've got if event is a key down and this. But now we've got multiple key down events that we can check. So we'll just break this out. Okay, so we have that. Then we can say otherwise. If we've got pygame key space, that's the one, then we should have a function which I'm going to call space pressed. And we'll call that function. Okay, so we can maybe make that a little neater, but that's fine. So we can sort of get rid of that. Now, handle keys, I'll get back. Actually, no, let's not get back to that in a second. Let's do that now. So I'll say, okay, the scene, set the spacebar status, and this keys is essentially a dictionary. And I'm getting tripped up because I'm saying keys more than once. Keys is a dictionary, and the keys of that dictionary are the codes of these key codes, and the values of these values in the dictionary are booleans, so true or false. So for status, we can go look into keys, look for Pygame space key, and that'll be either true or false. We can pass that along. Okay, so handle keys, handle mouse. I'm just gonna actually grab all of this again, because when we hit space, we want to, at that time, check what the key state is. Okay, so we've borrowed the keys from here because we need to know if we're pressing a WASD key while we hit space. Yep, that's good. Okay, I've got the function names right. Okay, so there are two parameters I'm going to keep track of, and that is the direction, which we're going to start at a deflection of 0 degrees away from the camera, and the amount, that's the forwards or left or right, whatever, amount. And okay, so if we're hitting W, then we're going forwards. We do not need to change the direction, but we do need to indicate that a forward step is being applied. If we hit A, we're going left, so we'll say direction is 90, amount is 1, and you can see what I'm doing here. Okay, cool. So we've checked and set any flags we need to set. So now we can go to the scene and we can, oops, try. We can attempt to jump the player with the, given direction, with the given forwards amount. Okay, so moment of truth. Let's fire this up. It's not going to look so good at the moment because it's a pretty basic scene, and for that reason I'm keeping the sky sort of fixed. So we can jump. That's the red component there indicating a jump. We can double jump. We can even sort of triple jump. Yeah, and we can jump and float. Oh, can we? I'll have to look at that. This line here might be messing things up a bit, because if we come up to jump, okay, so let's say let's just get rid of it for now. It's not a big deal. All right, let's run that. Oh, not even that. So we can jump, and there we are floating. Okay, so we can go jump, whoop. But yeah, and you can also see, okay, so here I'm walking and I can sidestep. I can jump and sidestep, but once I'm floating, whoops, it's not supposed to do that. Once I'm floating, I can only go forwards, but I can sort of float and then spin the camera around, and that will sort of theoretically move me around a little bit. This will be easier to see when I get actual scenery in the scene. But what was it? So another thing we can do is we can go to the model and just fine tune it a little bit. So up here where we move, Okay, so if we're floating, then yeah, we want to move forwards, and we also want the, where are we? We want to float a little more slowly, so we can sort of halve our movement amount, and that'll sort of simulate the... So this is a little hard to see, but we can go jump, slow, 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 and then we're moving a bit faster. It's very hard to see, very subtle. But yeah, that's it's not a perfect system, but seems to work. And we can also sort of to indicate this, we can go back to the model and we can just reduce that jump time. So let's say we only want to be floating for a maximum of 1 second. This will make it more obvious. Now we can run this, jump, float, and then it runs out. And then it runs out. So I'm pretty happy with 5 seconds. That's about how long it was taking in the game. And yeah, so a little bit very rambly, but hopefully this is an example of indicating how we could put in a jumping system. Anyway, hope you had fun, and I'll see you in the next one. Bye.